Welcome to our webinar, GR 1089 Core Issue 6 Update for NEBS. Thank you for joining us today. This webinar is being given by MET Laboratories. MET is a leader in the testing of electrical and electronic equipment for environmental hardiness, product safety, and electromagnetic compatibility. MET operates world-class labs in Baltimore, Maryland, Santa Clara and Union City, California, Austin, Texas, and also runs operations in China, Taiwan, and Korea. This webinar will run about 45 minutes with an additional 15 minutes for questions and answers. Due to the number of registrants, all attendees will have their phones muted. If you have a question, please type it in the questions area of your GoToWebinar control panel. We will attempt to answer all questions at the end. If you are having technical difficulties, you can contact us the same way or call us at 410-935-6053. That's 410-935-6053, and we will try to resolve it quickly. Just a quick note on other upcoming events. In April, MET is hosting a free NEBS testing seminar in Santa Clara, California, and a free international EMC homologation webinar. Register for these events at www.metlabs.com. Today's webinar is being presented by Asad Bajwa. Asad is Director of MET's EMC Laboratory. At this point, I will hand over the presentation to Asad.
Thanks, Barnaby. Hello, everyone. My name is Asad Bajwa. I'm the EMC Lab Director at MET Laboratories. As Barnaby mentioned, today we are going to talk about the changes to GR 1089 with the latest release, which is of issue 6. So let's start with that. Here is the brief outline of my presentation. I will very briefly touch base with the, go over the history of 1089 as over the years, how the changes were made to the standard with the emerging technologies in the industry. Then we'll go over the specific testing requirement changes from sections 1 to 3, and we'll compare between issue 5 and issue 6, and then towards the end of the section 3, we'll have a brief comparison between the high-frequency test method for 1089 and CISPR 22, which falls right into the changes of 1089 issue 6, where there is a discussion with the new release about trying to consolidate the testing where possible. Second part of the presentation will cover the changes from section 4 to 9, with major changes happening in section 4 and small minor changes here and there between section 6 to 9 and some of the changes in section 10. 1089 issue 2 was released in 1997. Over the years, we saw the first revision to that in 1999. Then issue 3 came in 2002, October. There were significant changes from issue 2 to issue 3. Then over the years, we saw issue 4 and then issue 5 in 2009. Between these changes, there were times when there were conducted emission voltage testing was required for EMC portion for DC power lines, and then those requirements were removed in the new versions like issue 4, so on and so forth. At the same time, there were some other changes which were of little significance in the larger picture. Our main focus today is going to be on the issue 6 and the comparison between the issue 6 and the issue 5. Issue 6 came out in May 21st of 2011, and at the moment this standard has been adopted by both Verizon and AT&T. Starting with section 1, the very first thing which the standard tried to tackle is the number of samples required for testing for 1089. For the folks who are familiar with the 1089 issue 5, they would know that for sections 2 and 3, the issue 5 said only one sample is required. However, for majority of the other testing, especially for section 4, standard required 3 sample testing, which could mean either testing the 3 samples as a whole, or in certain cases where there were multiple ports or multiple cards, then the requirement was to have at least those interface type testing, 3 cards of the same kind, so on and so forth. Section clarifies, the issue 6 clarifies further that only one sample is required now, and their main rationale is the cost saving for the manufacturer. However, in some cases, if we read through the specific detail in the standard, standard at some points give the option that if, for example, 3 samples are available and testing is done on the 3 samples, then the number of surges per port will be reduced. However, if only one sample was used for certain tests, then the number of surge per sample will increase. So there is a caveat there where manufacturer has a choice to choose between one sample versus the 3. The other major change in section 1 is the addition of requirement 1-2, which in a way consolidates and summarizes all the documentation and labeling requirements spread out throughout the different sections of the 1089. For example, section 2.5 of 1089 states there should be an ESD warning label on the products which are ESD sensitive. At the same time, the requirement 2-6 and 2-7 has additional requirements which relate to the user manual in terms of the installation requirements. Similarly, section 4, section 9, section 10 has more requirements. For example, section 10 states with the issue 6 that the product should clearly state with a label what is the normal operating voltage range on a visible place on the product. Now, all these labeling and documentation requirements are summarized in R1-2 for the convenience of the reader, and all this information has to be provided with either with the test report, and or some of them has to go with the installation manual, either in the form of CD, DVD, or as a web link where the end user could refer to should they need more information. Continuing on with section 2, the changes there are of various nature. One of the main changes is with the EFTB. Well, I mean, before I jump to the EFTB, let's go over the ESD part. Two main points of interest. There has not been a fundamental change to ESD, except that one, they are now referring in 1089 to the 2008 version of the IC document, which is 61004-2, and 2, they have clarified few items which were left vague with the issue 5. The number 1 clarification point is documented as requirement 2-2. The 2-2 covers the cases where the products have something like an LCD panel or a card ejector or something similar, some similar surface. The issue with the in many products with the LCD panels is per the requirement, you cannot use the Cont'd discharge, which we will go over in the later slides, on the LCD panel because it's a non-conducting surface, and therefore you try to apply in the lab environment the air discharge. And however, when a lab technician try to apply the air discharge, many cases, discharge, the ESD charge will try to jump to the metallic surfaces which are around the LCD panel. So in essence, the test technician is trying to apply the air discharge. However, charge jumps to the metallic surface. The standard clarifies in those cases, instead of trying to do the air discharge, the contact discharge need to be applied to the metallic surfaces around the surface like LCD, where discharge does not happen. This is not a new thing for the labs. Majority of the lab knew this thing based on the way the 61004-2 is written, the way the 61004-2 defines their contact and air discharge points should not be mixed. However, 1089 made a point to clarify this thing further so that everybody is doing this thing consistently. Now, the other clarification point was the how much could be the interval between the consecutive ESD zaps should a service affecting response happens. Again, this was nothing new from the testing perspective, because this thing has been clearly specified in 4-2, where the standard says if ESD anomaly is seen, the gap between the consecutive intervals can be increased, and standard purposely left it vague. However, with this release of issue 6, our 1089 is trying to harmonize clearly and trying to be consistent with what 4-2 says. Okay, continuing on with the section 2, as I mentioned earlier, the major change, I should say, is with the EFTB test method or procedure. The unique thing with 1089 testing is that oftentimes the products we are testing are much larger. Either they are floor standing equipment or they are rack mounting pizza boxes, or 1 RGU, 2 RGU like boxes. For a table type box, there is no change at all. It's as the IEC version of 61004-4 says. However, when we look at the 61004-4 verbiage for test setup, and we try to apply that to the larger racks, which in some cases could be as tall as 7 feet, if not longer, things become very complicated if we are trying to apply the cable distances as specified in 4-4 between the output port of the generator, the EFTB generator, and the port on the EUT side, because standard says you need to maintain a 0.5 meter distance between the EUT port and the output port of the surge generator. And if you're using a capacitive clamp, then same thing between the capacitive clamp and the EUT port. And just imagine the port is coming from the top of the EUT, as I will show in the next few pictures, and your port is about 6.5 feet high from the ground plane. Then you will be forced to come up with a strange arrangement where you will have to raise your ground plane from the floor level to 6.5 feet high and bring it as close as possible to the port so that you could maintain the distance specified in the standard. And this not only makes the whole setup very complex, it makes it very unsafe, because generally these generators are very heavy, and putting something very heavy at 6.5 feet with a makeshift arrangement, which is generally very flimsy, could fall off any time if care is not taken. Now, to avoid all those complications, to make the things simpler and straightforward, and before I go further, one thing I want to clarify is that in any EMC testing, the key word is the repeatability or consistency. In this particular case, the main issue was each lab was doing the EFTB test differently. trying to maintain the distance. Some will use the excuse, well, it's not practical to maintain this distance, and therefore they will keep the generator at the ground floor. Some other labs who will read the standard more, they will try to follow the standard more conservative. They will use a conservative approach. They will try to raise the generator high up and try to bring it close to the port. So this way, between the labs, the repeatability was not there, which was leading to much higher uncertainty in the test results. So to get rid of those uncertainties and to make the things more consistent, with this new release, the standard writers have added the clarity to make it consistent between one lab to the other. So I will try to explain that more with the few pictures in the next few slides. This particular set of picture shows a larger EUT, which does not have any supporting insulating supports like a cable trees. So in that case, standard says you need to just maintain between the EUT space to the capacitive clamp or the EFTB generator a 1 meter distance, and the cable distance between the EUT and the capacitive clamps of lesser importance. However, try to make it as small as possible. Similarly, if the EUT is set up using non-conductive support like cable trees, which are very commonly used in the lab environment, then standard specifies try to maintain a 1 meter distance between the capacitive clamp and the face of the EUT. However, again, there are no strict requirement on the physical cable length in this particular case. This next picture is the one which is coming from 61004-4 itself, and that was part of the problem which I was trying to describe earlier, where you would try to raise your ground plane high, which could be done. However, it's non-consistent and practically difficult and to some extent hazardous setup to do. Next section is the section 3, where we'll talk about some of the changes. The very first thing, which is described in section 3.1.4, is about the consolidation of the testing. Oftentimes, the labs already try to consolidate testing in an effort to provide more efficient test results, and at the same time try to be more provide more cost-saving compliance solution to our customers. With the issue 6, standard has provide more clarity to already existing industry practice. So in essence, what they're trying to say is that if a product is meant to be qualified for multiple countries or standards, for example, it is supposed to go to Europe, it is also meant to be sold in North America, then you will be looking at the standard like 336, GR39, FCC, so on and so forth. So the way they are describing is that an effort should be done to try to consolidate the testing in a way that rather than running 3 or 4 different radio emission tests, for example, a single test could be performed to meet the need of all these 3 standards where possible, where practical. And it's well understood it may not be possible in all cases. However, in many cases, labs can run some sort of analysis and come up with a test plan which will allow them to consolidate 2 or 3 tests as a cost-saving effort and as an effort to increase the efficiency. So in those cases, 1089 allows to consolidate the testing where possible. However, if a failure happens during this consolidated testing effort, testing for individual standard have to be repeated in order to identify what was the cause of the failure. The other changes, the older section 3.1.4 related to FCC Part 68 has been removed. Throughout this document, many of the test requirements related to analog ports have either been removed or has been consolidated with the other conducted emission testing, similar to like IO line testing. The next change is with section 3.2.1, where the requirements, the radiated emission requirements for both radiated emission electric field and radiated emission magnetic field has been removed. Historically, the testing requirement from 10 kilohertz to 30 megahertz using active rod antenna been there for a long time. However, due to the much higher uncertainties with the active rod antenna and the active rod antenna calibration, there were always a question about the validity of this test from 10 kilohertz to 30 megahertz. And I'm very glad to say that finally the standard writers has listened to the industry demand, and this particular requirement has been removed. Now there are other changes related to the radiated emission, which I mentioned. There've been the removal of the magnetic radiated emission magnetic field. Similarly, the conducted emission testing for analog voice band lead has been removed. However, the 10 kilohertz to 30 megahertz testing for conducted emission is still there as a conducted emission current test. The other addition there is the permission to use either the NC C63.4 2009 or 2003. The main advantage of allowing to use 2009 is that in many cases, as I mentioned in the previous slide, that during a test program, labs will try to do tests like FC336 or CISPR22 while they are trying to do the radiated emission testing from while they are trying to do radiated emission testing for FCC or 1089. The issue was the 2003 version of the NC did not allow to have absorbers on the floor between the turntable and the receive antenna from 1 gigahertz to 6 gigahertz. Whereas with the CISPR22 2006 amendment A1 of 2007 and now the 2010 version of the CISPR22 require that there are absorbers in order to achieve the 6 dB VSWR requirement between the turntable and the antenna. So by allowing the 2009 version of NC, which is pretty much practically harmonized with the CISPR22 requirements, labs would not have to perform two separate tests. They can achieve the compliance for 1 to 6 gigahertz for FCC and or CISPR at the same time using one test setup, which is in a way saving a lot of saving on the test timing. Okay, a little bit rationale. I will just go very briefly through this. We have a lot of ground to cover. The main reason why the 10 kilohertz to 30 megahertz testing was removed, fundamental reason I mentioned earlier is the way the active rod antennas work, the way there are much higher uncertainties with the antenna calibration and the design of the active rod antenna, considering the much larger wavelength of the frequencies from 10 kilohertz to 30 megahertz, an efficient antenna would be of the order of somewhere close to 8 feet, which is not practical even in a 10-meter chamber. However, if somebody is doing this testing in a 3-meter chamber, the results will have way too higher uncertainties. At the same time, based on the analysis of the large number of the products in the industry, the threat level from 10 kilohertz to 30 megahertz is very, very low to the products being used in the telecom industry today. Finally, the noise emission from these frequency ranges, i.e., from 10 kilohertz to 30 megahertz, is primarily covered by the conducted emissions on both the power and IO line as a conducted emission current test. So that threat, even though it's very low risk there, is still analyzed, but however as a conducted test. Okay, very briefly, these antennas are gone with the changes to 1089. These antennas, which covered from 30 megahertz to all the way up to 40 gigahertz, are still needed. I had these antennas there just as a information for the interested listeners. Next testing is the conductor emission test for analog voice band leads, which has been removed. Now, as the technology is changing in the industry, a lot of tests relate, and we are seeing a lot less analog products out there. The tests related to analog leads, majority of the tests related to analog leads have been removed, and they've been being treated. The analog leads are being treated as other telecom ports, and the conducted emission test on them will be performed as if they were the other IO lines mentioned in the standard. Conducted emission testing on AC and DC power cords have been unchanged from issue 5 to issue 6. Okay. Regarding the immunity, the conducted immunity testing, few changes there. As far as the frequencies of key interested are there, the analog, the 55.2 megahertz FOCI has been removed, which was there as part of the issue 5. The conducted immunity levels for analog voice band leads still are different as far as the conductor susceptibility is concerned. On the power, AC and DC and signal lines, all of them has to be tested now to the same level. For the folks who are familiar with the testing for issue 5, they would know that the previous version had different test levels for AC/DC and for the signal leads. I mentioned in the previous slide the frequencies of the key interest. The table 3-15 on the left side of the PowerPoint is from the 1089 issue 5, and the one on the right hand side is from the issue 6. What I want to show with this slide is that two of the frequencies have been removed. One is 55.25, which was for the analog TV channel 2, and the other one is the PCS band, which was 914 megahertz. However, a whole bunch of different frequencies has been added as the frequencies of the key interest. One under police and fire radio. Then there are others under cellular telephone and And obviously the PCS band 914 has been removed, and there's only one which is at 1800 megahertz. In other words, for radiated susceptibility, there will be a little bit more test time compared to the issue 5. Next few slides are there just for the folks who are unfamiliar with the 1089, and I will try to spend a very little time on these slides. I want to focus more on the changes which happened from issue 5 to issue 6. However, I just wanted to briefly mention a few keywords there for the interested participants so that they get better familiarity with the testing requirements for 1089. So our 1089, the way the testing has been organized, they talk about the requirements, they talk about the objectives, and each requirement and objective will have a number with the letter R and O signifying its requirement and or the objective. Requirements are the tests which should be performed and product should comply with that particular requirements. Objectives are the tests where testing should also be performed. However, compliance is desired. Compliance is not must to meet the overall 1089 compliance requirement. This slide shows all the tests which are performed as part of the EMC section, which are the section 2 and 3. Electrostatic discharge, which is covered in section 2. Very briefly, the tests are defined as normal operation and installation and repair. Normal operation is the application of the the air and/or contact discharge as applicable to the areas which will be accessible to the end user during the normal operation of the device. It also includes the hinges of the door and in the inside of the door if the product has a removable door or a panel. Installation and repair means the ESD testing to the surfaces and the areas which are behind closed doors or removable panels. Issue 6 now refers to the 2008 version instead of the older version. The test levels are the same from the previous versions, which is plus minus 4 kV and plus minus 15 kV air discharge. And regarding the contact discharge, it's done at plus minus 8 kV. Typical ESD waveform, which is based on the human body model. This is a sample of the test points. Standard obviously cannot give the exact location of the test points. However, standard gives the guidelines, and the labs use those guidelines to determine which areas and or surfaces of a product has to be tested for contact or air discharge. The only change in that regard is related to the LCD panel or card ejector and similar surfaces. In this particular picture, what we're trying to show is that where the crosses are, those are the areas where a contact discharge is applied, and where there is an O there, that indicates a non-conductive surface like an LED or a non-metallic surface like a plastic or PVC ejector or something like that, where the air discharges would be applied. ESD warning label, I mentioned as part of the requirement 1-2, the test report and the UET documentation, which is also covered under requirement 1-3, 1-2 and 1-3. All the documentation has to have the applicable statements, labeling requirements, etc. In this particular case, the product has to be furnished with the ESD warning label. The standard says if the product is ESD sensitive, then the product should be furnished with the ESD warning label, similar to what I have given one example, but there are other permissible warning label which could be used, which are defined under EIA 471. One point of clarification there is that there is a lot of debate in the industry, and oftentimes speaking with our customers, this question comes up where there's an argument in the industry that during the testing, product passed with flying colors. No non-compliance was observed. Do I still need the warning label on my product? Because apparently my product is not ESD sensitive. The question to that is depends on who you're selling. Verizon's position on this is very clear, which is the Verizon position on their website, and they have updated their, I think last year, where they clearly say that they consider all the electronic products to be ESD sensitive, regardless they show any signs of anomaly or any susceptibility signs during testing in the lab. Therefore, all the manufacturer who would be selling to Verizon, they need to have ESD warning label on the product. Moving on to the electrical fast transients, we briefly covered this already as the part of the changes to Section 2. This one particularly refers to 61004-4. The test levels are 0.5 kV for types 3 and 4, and 1 kV for customer premises power ports, 0.5 kV for non-customer premises power port. It's a fairly straightforward test which is applicable to both power lines and the IO lines. A typical waveform which is coming from 61004-4, which shows the pulse shape, and it shows the pulse duration, which is 50 millisecond burst, and the burst period is 300 milliseconds. Okay. Moving along, the next portion is the emissions and the immunity requirements. I'm not going to spend too much time on the emissions portion. We pretty much already covered all the changes there. The only point I will try to make is that, which oftentimes leads to some confusion, is that before we start the testing, the lab try to analyze a product and determine whether the product has a removable door or panel. If product does have a removable door or panel, then we start testing for radiant emission with the door either open or removable panel removed, and we test to the closed door requirements. And if the product passes the radiant emission testing, then we consider it meets the open door requirement, it meets the closed door requirement, and it also meets the objective. However, if product fails the objective, then the next step is to close the door and test the product to the closed door limits, and then make a determination. If it passes, it's considered pass. If it fails, it's considered fails. These are the limits for radiant emission. I left there just for reference only. Another point of clarification, the older version, which is shown on the left side, said there need to be 1 feet spacing between the top of the rack and the cable tray. I'm sorry, my apologies. The one on the right, the cable setup is practically the same. The older document said up to 2 feet. The new document says it's 1 feet. The Verizon and AT&T document, which is part of their checklist, everybody today conforms to the diagram which I have shown on the left, where assuming a 7 feet cable, assuming a 7 feet telecommunication rack, there need to be 1 feet cable spacing between the rack and the cable tray, and there need to be about 12 inches of spacing between the rack itself and the cable trays. In the past, there have been a lot of changes back and forth between 1089 and over the years. Now everybody is in agreement, and all the labs and all the applicable standards refer to this particular setup for the sake of consistency. Radiant emission testing above 1 gigahertz. I already mentioned that. This particular testing, 1089 requires testing to be done at least up to 10 gigahertz. However, if this product goes to a certain location where the product must, where it's not exempt from FCC exemption list, and FCC Part 15 does apply, in those cases, product has to be tested up to 40 gigahertz as well. In the next few slides, the comparison I want to show is between the 1089 testing / FCC testing versus the EN55 or 22 testing requirements. The small caveat there is that the original requirement came under EN55 or 22, 2006 with Amendment A1 of 2007, and now a new rep came which is of 2010. So during the presentation, I will be referencing to 2010 version. The CISPR 22 2010 version says if the EUT clock is greater than 108 megahertz, then testing has to be done. Testing may have to be done up to 6 gigahertz depending on the clock frequency. The following slide shows the comparison of the peak and average limit from CISPR 22, which is blue and the pink lines, with FCC average limit, which is the red line. As you can see, the CISPR 22 limit is lower up to 2 gigahertz below the FCC average line. What it means is if somebody passed the FCC requirement in the past and their margin was less than 4 dB, and now today they want to go for CISPR 22 testing, there is a slim chance that they may see a failure to the CISPR 22 requirements. So it will be a very good idea to go back and revisit that testing to make sure that there are no last-minute surprises there. This plot shows the analysis between the FCC or 1089 method versus the CISPR 22 method, where we can see using the CISPR 22 method, where there are absorbers on the floor, that has been shown with the orange trace, which is from up to 3 gigahertz. We can see the results are way lower, and that kind of conforms to the reduction in the limit which we saw on the earlier slide. This is a typical setup picture where absorbers are placed on between the turntable and the receive antenna. In many cases, depending on the chamber construction, labs can and are permitted by the standard to use absorber on the turntable around the table or around the test rack. One point of clarification is that with the permission of using NCC 63.4 2009, practically the test method between CISPR 22 2010 and 1089 is the same. However, care should be taken to make sure the documentation clearly states in the report that which version of the NC document is being used. I will very briefly go to the conductor emission testing. No fundamental changes. There is CEV AC power, which covers 150K to 30 megahertz. Then there is conductor emission current requirements, which go from 10 kilohertz to 30 megahertz. Similarly, there are CEC telecom requirements. I originally planned to go over the immunity requirements, which were part of the 1089 section 3 as radiated susceptibility and conductive susceptibility. However, as I can see, I'm kind of running out of time, and I'm going to skip the portion where we are talking about the radiated and conductive susceptibility, also keeping in mind there are not too many changes from that angle. The main changes are there in terms of some of the limits changed, and at the same time, new focuses have been added, which we have already covered. So I'm going to skip that portion, and I'm going to jump straight to the section 4, which has a lot more changes there. Okay, section 4. Section 4 covers the lightning and the power fault. The way I have tried to organize this portion of the section 4 presentation is to talk about what testing requirement has been removed from issue 5 when the issue 6 came, and what are the other tests which are no longer applicable. Then we'll briefly go over the new equipment types, and then we'll talk about the some of the test requirements based on the new protector technology. This is the listing of the testing which is no longer required, one of which is the conductor emission requirement for analog lead. This is obviously based on the trend in the industry. Similarly, the objectives like O4-3 and 4-4, which are about the interfaces for receiving power, remote power, they have been removed based on the changes in the protector technology. The test flag 600 volts, AC power fault, they have been removed, and the 1000 volt 5 test have been removed. Moving along, from section 10, single voltage transient and voice frequency noise emission has been removed. Similarly, the broadband noise emission test method has been removed. With issue 6, the standard writers try to reorganize the section 4 altogether. The older version, well, I need to be careful what I say. The older version was not very well organized. With the issue 6, standard writers did an extra effort to reorganize and make the issue 4, the issue 6 of section 4, a lot more clear and in a very logical manner. So starting with the introductory information, they try to combine it at one place. Then they talk about some of the new design requirements, and then they have taken the table which were haphazardly throughout section 4 at multiple places. They combine them together and list all the lightning and power fault testing in 1 or 2 tables in a consolidated form, so that it's easy to read and correlate different test requirements based on the interface types. We'll be looking at that very shortly. Okay. Metallic interfaces. From type 1 to type 8, especially for the folks, for the participants who are familiar with the 1089 issue 5, those types have always been there. Central office to outside plant, central office intra-building, antenna port, which is type 6, AC power ports, type 7, DC power port, type 8. They had always been there as part of the 1089. However, with issue 6, there have been few more metallic interface types been added, and there are tests related to those new interfaces. For example, type 3A and type 3A and 5A, which is the intra-cell side cable, meaning the cable between the cell side boxes and the enclosures. As these interfaces are generally not for very long distances, they are defined as short distances. So AC power fault is not a concern. The primary concern in this kind of interface is the GPR, and in the following slide we will touch base on the GPR, how it becomes a threat. The type 3B and 5B are short reach OSP cables. Again, they are generally less than 500 feet, so the risk of lightning and power fault is relatively very, very low. Then there is type 4A, which is the customer side ONT. With the new technology, like with the ONTs, with the ONTs being installed many places in the US, now we are seeing more and more of the, my apologies there, we are seeing more and more of the ports or the Ethernets which are coming from the boxes like ONT, and they are defined now as type 4A. Type 8A is the DC power for the antennas, and type 8B is the intra-cell side DC power. Again, these interfaces have very limited exposures, and they run very short distances if they run outside. Again, like type 3A and 5A, major concern is the GPR, and the AC power fault is not the concern because of the short distances they run at the typical sites. For the folks who are new to T1089, again, I have added another definition there, which is the first level lightning, and I'm sorry, I should state it clearly. First level test and the second level test. The first level criteria basically assures the product is functional. It assures the functionality. The way the verbiage in the standard is, it states UT including the host system shall not get damaged, and it should continue to operate when the device meets the first level criteria. The second level criteria assures that there is no fire hazard. Device does not, or UT does not cause any fragmentation or other safety related concerns. UT can take a hit, UT can get damaged, but it should not become a hazard. That's the second level criteria, and we'll look at that as we go through. Section 4.6.12.1 covers the first level lightning search. It defines the lightning testing for port types 1, 3, and 5, then 5B and 3B and 5B, which are short reach, and the testing requirements are very, very similar to the port types 1 and 3. Based on the newer technologies like gas tube, their gas surge arresters, there are tests like first level tests for types 1, type 1, 3, 3B, 5B, and type 5. The test levels go as high as 4,000 volts. The waveform is 10 by 700 and 5 by 310. Excuse me. Continuing on, section 4.6.12.1 covers the fast rise time test, and it also covers the higher ground resistance test. Again, my apologies, we are kind of running a little bit short on the time, so I'm going to skip some of the details and the test levels, which I already have mentioned in the PowerPoint, and this PowerPoint will be available by tomorrow on our website if somebody want to use it as a reference. So I'm going to skip some of these test levels there, and I will focus primarily on the changes which are happening from issue 5 to issue 6. This particular slide covers the GPR, which is primarily a concern of the cell site. The way the ground resistances are at many of the locations, depending what radial distance the different enclosures and boxes are grounded at a given cell site, there could be significant potential difference between each enclosure or the piece of equipment, which can lead to serious concerns and problems and cause serious threats to the functionality at the test sites. Continuing on the lighting search, again, for the ONT interfaces, which are covered by type 4A, plus minus 1000 volt, 100 amps. For the tower treating DC type, which are covered by type 8A, the test levels are plus minus 6000 volts. There are no changes to the antenna port testing. There are no changes to AC power port testing. First level lighting exemptions for types 2 and 4. Standard has come up with a lot more exemptions for type 2 and type 4. It says no testing is needed if the ports are within the same frame of the cabinet, within same lineup and within 6 meters. Port is for maintenance only and not normally connected. Okay. Then there are exemptions for longitudinal testing if the equipment is not grounded, has no ground connection and no power. Okay. For type 2 Ethernet ports, they are exempt if the port has no secondary voltage limiting protection. Up till August 1 of 2012, our type 4 and 4A Ethernet ports are exempt from the metallic test. Afterwards, the manufacturer will be required to perform these tests. We highly recommend to our customer, at the minimum, to try to get these tests done in the lab to get a feeling of how their product will behave when they are exposed to this kind of testing. Those were some of the fundamental changes to Section 4. There are a few minor changes as we go along. Unfortunately, again, I have to skip some of these slides here, and I will go straight to the Section 5 and onwards. I'm really running out of time here. Number of samples part we already covered. I want to before I go to Section 5, just want to briefly mention Section 6 and 8. They are practically the same. Section 6 covers the DC potential and Section 8 covers the corrosion. They are practically unchanged. No changes there from issue 5. Regarding Section 5, which is the steady state power induction, there are obviously no major changes. As I mentioned, there are additional guidances provided for the different various technologies. Standard has specified specific loop lengths, and standard highly recommends using the actual cable length instead of the simulators. Similarly, the ISDN related testing has been removed, and the COEX performance criteria has been removed from the Section 5. Section 7, electrical safety. The POE has been defined exclusively as type A1. Then there's a new section added to reference to the laser safety standard. The next thing I want to mention, which continues to be the bone of contention even today, is the bonding and the grounding as covered by Section 9. The main thing there is that standard specifies all equipment certified by an NRTL like MET Lab are exempt for the short circuit test as defined in section 9.1. Now the question is what it means. Many folks will think that if testing is done by NRTL, then no testing is needed at all. Now, from a lab's perspective, we will have to evaluate that the components, the DC-DC bricks, which are being used in the product, were they specifically tested during the NRTL testing? Or there was just an analysis performed during the NRTL, or just an analysis was performed and the NRTL report is based on the analysis only. So this is an ongoing debate in the industry. We'll find people on both sides. Some will claim if the NRTL did not actually perform the testing of the product, then lab must perform the testing. There is the other group who will say, well, standard clearly states that if NRTL report, only the NRTL report is sufficient, therefore it doesn't matter whether the testing was performed by NRTL or not, the report should be sufficient. However, our position is that we will analyze the report, we will evaluate the report, we'll want to make sure which components were tested by NRTL, and based on that we'll make a final determination whether additional testing is required or NRTL report can be accepted. We've been approaching Telcordia to get further clarification on that, and we are waiting for a final answer from Telcordia to clarify what exactly was the intent there. At the moment, there are still open questions by everybody in the industry on this particular requirement. Then continuing on, for embedded power source, if the rating is less than 15 VA, they are exempt for testing. If the rating is greater than 15 VA and they are not NRTL listed, they shall be tested to section 9.10. The last part which I want to tackle is the section 10 of 1089, which is the DC power source. In essence, there are not too many changes. However, if we compare the issue 5 versus issue 6, the issue 5 had documented the requirements and objective with far more clarity the way compared to what issue 6 has today. If we look at a little bit the history of 1089, before section 10 became part of this 1089, it was a separate document as NCT 1.315, which later got obsolete and became ATIS 600315. So the earlier version of 1089, they kind of simply copy-pasted the NCT 1.315 requirement and made it part of the 1089, and they had a lot more clarity there. With issue 6, they kind of took the reverse approach, and they removed pretty much everything from the standard and said, follow ATIS 600315 document, which has led to some confusions here and there throughout the document. So let's look at that. One change there is that there is the addition of 10.4 over voltage transient, which is very, very similar to the AT&T requirement. The other change there is that they defined a new test criteria under section 10.5. However, if you look through this, there is nothing new except that they have combined all the criteria which were part of the issue 5 as impulse, under voltage, over voltage, transients, and lumped them together under section 10.5. So in essence, that is practically the same. However, they have reworded this thing. So if I go back and look at the ATIS document, the under voltage requirement, the tolerances, fall time, rise time, they are all the same. No changes there. Just for interested participants, the under voltage, we go from 50 volts to minus 5 volts. The rise time is 10 microseconds, fall time is 5 microseconds, duration has to be 10 milliseconds. Similarly, the over voltage, the fall time should be less than 2 microseconds, and then 10 millisecond duration. Slope has to be 10 volts per millisecond. The other thing which has been made part of the document is that, specifically the NS document, is that now they are clearly specifying to use resistive load. Well, resistive load is one of the options. They still are giving 3 or 4 options to calibrate the generator for section 10.5, and resistive load is one of the most convenient methods to validate the generator. MET Lab today has a capability of going up to 300 amps at the minimum, and we can perform the under voltage, over voltage transients up to 300 amps very easily. Okay. The other changes are the 10.6 noise return criteria. The change there is that the minimum current requirement has been changed from 1 amp to 10 amps. So in other words, this change basically supports the manufacturer. The limits were originally based on 1 amps. Now the limits are based on 10 amps. So limits are in essence higher, and it supports the customers basically at the end of the day. 10.8 I kind of already covered, where as I mentioned earlier under section 1 that all the documentation and label need to be provided, and in this particular case the requirement is to clearly state what is the nominal voltage range for a given product. Finally, at this point I just want to briefly mention that about telecommunication carrier group, which was formed several years ago. The intention of that group was to, rather than having each RBOC its own different requirement, try to harmonize the requirement where possible. And then at that point, Bell South, Quest, AT&T, and Verizon came up with what we call telecommunication carrier group. And today we have 2 main carriers, Verizon and AT&T, who are still maintaining this telecommunication carrier group. And all the information about TCG group and their checklist, which I have listed there, can be found at www.verizonnebs.com. At this point, I'm going to say thank you for your time, and thanks for listening to my presentation. I hope information was useful. I wish I had a little bit extra time and I could spend more talking about some of the fine details in section 4s and other parts. Benabi, could we go over the questions?
I think we're about out of time. If anyone has an unanswered question, if you could forward it by email, or you can call us, we'll be happy to answer any questions that way. And we will also be sending a follow-up email tomorrow that will include a special offer and a link to the presentation so that you can download that. That concludes our webinar today. We thank you for joining us, and we hope you can keep in contact with us.